good afternoon. Welcome back.
Hello.
Hello. So we're working on 7-4, parallel lines and proportional parts in triangles and in lines. If a line, hang on, I got to get my sheet notes. All right, so if we have some line and it's parallel to one side of a triangle, and this parallel line intersects the other two sides of the triangle, then it's going to divide those sides into segments of proportional length. I cannot spell today. All right, so take a look. We have to have already marked for us parallel lines. Okay? Start with parallel things. And then the segments, oops, that was supposed to be a light blue, sorry, are like this. Notice that the segments, the pieces of the side of the triangle, are in the same fraction as each other. And notice that the sides that are the same kind of length, like the long ones, are all in the same portion of the fraction as each other. Okay? All right. The converse of this, the triangle proportionality, the converse of the triangle proportionality starts with a triangle and has a line that intersects them. And this line intersects them such that we can create a proportion. Okay, so one of these has where the lines are parallel gives us a proportion, and here we have a proportion being able to give us that they're parallel. Okay? So this one we use to do our calculations, and this one we'll use to do our proving, basically. And the last one is the midsegment theorem. Midsegments. A midsegment of a triangle is perpendicular to one side of the triangle, to the side that it's not running into. And to remind you what that midsegment is, here it is being parallel to the side that it's not running into. But because it's a midsegment, it's going to cross these other two sides at their midpoints and make the pieces on either side of that midsegment congruent to each other. When you have this setup, its length, this length of the midsegment, is going to be 1/2 the length of the side that it is parallel to. Okay, here's your formula. Midsegment is 1/2 of the side that it's parallel to. That's it. That's the whole formula. Okay? All right, let's do some practicing. We're going to work on just the setup again because you guys are feeling really, really comfortable with the cross multiply and solve. And so I'll only do that when it looks like the algebra is getting weird. And I want to show you some tricks. Bless you. All right, what setup do we have? We do have parallel lines, which means we are looking firmly at the triangle proportionality theorem. And that theorem says this side can be written as a ratio, which is equal to the ratio of these two things. And so my setup is going to look this way. Please remember that everything on the same side of the triangle needs to go together on the same fraction in our proportion. And things in the same space, the same location of the triangle, need to go together in the same location of the proportion of the fractions. Okay? Let's do one more setup. Setup for number 2. Not solving. You will solve on the homework assignments. You will solve. But for right now, we're just doing the setup because that's the hard part. What do we have?
We have 2 parallel lines.
Okay. We have parallel lines, which means that this side of the triangle can be written as a ratio, which is equal to the ratio we get from these two sides. And again, remember that everything on the same side of the triangle will go together on a fraction in my proportion. And everything in the same location of the triangle will go in the same location of the fraction of the proportion. Okay? So that's the only thing that's important, is that you make sure that those match up in that way. Okay.
And then we cross multiply and you
Cross
solve.
multiply and solve. Yep.
It's super easy.
Super, super easy once you get the setup. It's the setup that's hard. So that's why I'm focusing on just the setups. All right, we're looking at this one. What do we have?
We have two parallel lines, and we see 2 congruent lines as well.
Which means this is half, which means this is the midsegment. Yep. Looking at the midsegment theorem. Here's our midsegment theorem. Remember that theorem says that the midsegments
And the triangle is parallel to
is
it.
equal to 1/2 whatever we get from the side it's parallel to. And crunch the numbers and done. Yes? Okay, let's turn the page. Number 4 setup we've done. I want to look at number 5 because the setup looks like it might be a little more challenging. Yes?
Yes.
All right. What do we have?
We have 2 parallel lines,
Okay.
and we have a side that we can solve right away, which is that one, because 11 minus 33 would be 22.
Other way around, 33 minus
Yeah,
11.
33 minus 11 would be 22.
Okay. And so what's the setup?
XO plus 12 over x is equal to 22 over 11.
All right. So he basically said that I could write these as fractions, and I just have to be very careful and make sure that the things on the same sides of the triangle are in the same fraction as each other, and that pieces that correspond are in the corresponding pieces of the fraction. Okay, that's really going to be the hardest part about the setup. Whoops. Now I do want to take a moment here and work through a little bit of the cross multiplication, just because it's still a little concerning for some, which is this right here, dealing with how do I multiply these two things together. The best way to deal with the multiplication of these two things is not to multiply them right away, but to write down, hey, I'm totally multiplying these right now. And then to notice that we can distribute. Um, 121? It's 121? Okay. Calculator app that someone for me because...
Oh, wait, no, it's 132.
Oh, it's 132.
That's right. That's 132. Is that 11?
Yeah, I don't... I can go to my 11s up to 9 and then I stop because
Oof.
I don't know the rest. Calculator, please. I'm done. I quit. Okay? Number 6. Same sort of setup.
Yeah, it's super. It's like the same thing.
It's the exact same thing as 5. Okay, good. 2 last theorems. Proportional parts of parallel lines and congruent parts of parallel lines. We're going to do the proportional parts first. If 3 or more parallel lines, so 1, 2, 3, intersect two transversals, 1 and 2, then those parallel lines are going to cut off the transversals proportionally. That is, they're going to create segments that we can write in proportion.
Whoa.
Okay, take a look. We've got parallel lines. Okay, AB. AB is right here.
And BC is right under it. And that's supposed to be proportional to EF and that was right under it, FG.
So notice that the things that are on the same transversal are in the same fraction. And the parts of the transversals that are within the same space of the parallel lines are in the same space in their fractions. Okay? That's going to be the only tricky part about these setups. Yeah? All right? Okay, let's look at the congruent parts and then we'll do some examples to get this to make more sense. If 3 or more parallel lines, 1, 2, 3, cut off congruent segments on a transversal. Okay, so here's our congruent segments. We have one here and one here. Then those parallel lines are going to cut off congruent segments on every other transversal that we could possibly draw. Okay, let's practice. What? Wait, he's thinking. I'm thinking. Let me fix some colors here real quick. Alright, so if these parallel lines, if we look at one transversal, if these two pieces are congruent to each other, then in any other transversal we might happen to draw, these pieces will be congruent to each other. That's it.
So that means you only need one angle to have a side similarity.
Right. If we had some triangles in there, yes. Alright, let's set this one up. What do we have?
We have 3 parallel lines and 2 transversals, which must mean that x plus 12 is over 12 is equal to 5x. over-
Yeah, it means that these pieces of the transversal can be written as a fraction, and the fraction will be equal to those two pieces of the transversal written as a fraction. And again, remembering that things on the same transversal should be in the same fraction as each other, and things within the same space of the parallel lines should be in the same space as each other on the fractions. And then we're asked to solve this nonsense. Process remains the same for the cross multiplication. I actually want to solve this one out for you because there's a skill embedded in here that you will need for Algebra 2. So I would love to be able to give you a jump start on that. Okay? It's a skill that you've seen before, but you're going to practice it a lot more next year, and I just want you to feel ready. All right, so actually I'm going to do these first. Okay, I've got 2 terms on one of them, so I'm just going to write that I need to multiply them, and I'm not going to think too hard about it. And I'm going to write that I need to multiply these 2. Now I'm going to do my distribution. 3x times x is
3x squared.
3x squared. And 3x times 12 is
36x.
36x. And 5x times 12 is
60x. Boom.
what you're looking at is a quadratic equation. It's called a quadratic because the biggest exponent on x is a 2. Anytime you have some of this stuff, the first step you want to do to solve it is make one side 0. Do whatever you need to do, and it doesn't matter whether you pick the left side of the equation or the right side of the equation, just make sure that it's equal to 0. I'm going to choose the right-hand side because there's less work involved to make that 0. Okay? So I'm just going to subtract 60x from both sides.
Oh, I did it.
34?
Yeah, I'm subtracted the 30.
Yeah,
the 20.
24?
Yeah, you subtract-
24. Okay, I'll believe you. I don't number well. And now we need to solve this thing for x, which looks freaky to do because we've got two x's that I cannot combine using addition because they have different exponents. So I can't add the 3 and the 24 together.
Do you divide them all by 3?
I could divide everything by 3, yes, because both of those are divisible by 3. But the process I want to show you is called factoring, and I want to factor out the greatest common factor. Okay, of which 3 is one of them, those factors. So you're going to see it. What I'm going to do first is I'm going to take each of these terms and I'm going to write them as a list of all the factors that are needed. Okay, so what do I need to multiply to get to 3x squared? Well, a 3 times x squared, obviously. 3 times x times x. So those are all the factors kind of listed out and broken apart.
I remember this.
You remember doing this?
Yeah.
It's come back to haunt you. Being able to see quickly that they're both divisible by 3 is going to help make this simpler. And you don't have to write down this part if you can do it in your head. But if you can't, I'm writing it down so that you can see what's happening. So it doesn't look like magic. Okay? What do I need to multiply together to give me negative 24x?
8 times 3, well, negative 8 times.
Okay. Essentially, we need negative 24 times x. But because I want common factors, I want to break 24 into things multiplying together to give me 24, where one of the things is 3, if possible, which it is as 3 times 8. And since I want a negative 24, I want 3 times 8,
Times x.
but I want this 8 to be negative so that this 3 and this 3 stay looking the same. Because 3 and negative 3 aren't the same thing. All right? Now that I've gotten the list of all of my common factors, I'm going to circle the factors they have in common. They have a 3, so I'm going to write that down.
They have an x.
They have an x. Oh, the greatest common factor is 3x. And then in parentheses, I'm going to write whatever I have left over. And if I have more than one thing per term left over, I'm going to multiply those things together before I write them down. Okay? So I want to make sure that I'm thinking in terms of those terms. Okay? That those are separate creatures that I'm dealing with. We okay with that part?
Yeah.
Okay. So star this if you keep nothing else from my notes this year. Make sure you keep this section and you refer back to it because this will save you in all the factor you need to do all the way up through Algebra 2, Pre-Calculus, Calculus 1, 2, 3, and differential equations if you're going that high in your math studies. I don't know where you're going to stop. Just depends on what you're studying. Okay, and all of that mess equals 0. It's not solved yet. Because remember, to get it solved, you want variable by itself, stuff on the other side of the equal sign. But whenever I have stuff times more stuff, and that equals 0, the something in the stuff had to be 0. Right? Because stuff times 0 is 0. Which means
X equals 0.
this thing could be 0. You're not wrong. Or
This
this thing
could be 8,
could be 0.
which is
And now I have two really easy to solve equations. 3 times something is 0. What's the something?
0.
0.
I have something minus 8 is 0. What is the something?
8.
And you're done. These are all the possible values that x could take. And still keep this proportion thing happening.
Yep.
Now, put on your I am now a city planner hat. Okay? Your city mayor has come up to you and said, I need you to design these streets, but I want these streets to be in a ratio 5-3. And they gave you this setup because they really loved this example when they were in high school, and so they want part of their city to have this. So that every time they look at a map of their city and they see this, they go, that was my math problem in high school. And they'll just get a giggle out of it, okay? It's not as weird as it sounds. My parents did that for a living when I was growing up. They drew city maps. I'm not even joking. They planned out where the streets went and everything. Yeah. I'll tell you the story after. Okay. So, you do all this work and you go, okay, I can either have x is 0 or x is 8. And the question is, I can't have a street that's both of these at the same time. It's either one or the other. And so which one should we pick to make these streets work out? Well, if I make x equal 0, if I allow x to be 0, what becomes the size of this street? 0. There's no street there, which doesn't work if you're trying to put buildings. It just doesn't work. So if you were going with what's realistic, x equals 0 is not a reasonable answer. It is an answer. It's just one that if you try to build it, doesn't make sense. Okay? I am not looking for what is a reasonable solution unless it's a word problem thing and we're starting to talk about it relating to real life stuff. If we're just talking about, hi, let's play with numbers and shuffle symbols around, all possible is what we're looking for. Fair? All right. Let's look at number 8. What's our setup? Congruent parts, because I've got some parallel lines happening here, here, and here. I have one of the transversals getting chopped into 3 equal pieces, and that implies that the other transversal got chopped also into 3 equal pieces. And so I get to write an equation with any 2 of those that I want that's the easiest for me to solve. No one cares which 2 you pick. Just pick the one that's easiest for you. The one with the least amount of stuff, that works. That makes me happy and easy, and yes. And I'm done.
Oh.
No one cared which 2 you picked, as long as it was ones that made sense to you. Super easy. Do you need to see setup on any of the other? I have 2 more examples.
No, we're
One of each kind. I can show you to set up again if you want.
no.
Nope, we're happy? All right, that's all I had for you today. Thank you very much.
Wanna do it now?
You want to do an outro? Because it's been forever?
Yeah.
All right. That was like a Wookiee. All right, so that was a Wookiee. Let me translate. Put on my Wookiee translation hat. Thanks for watching, and we'll see you in the next one. Bye.